Hi there. Today we will replicate a real-world power system model. Okay, let's get started. Here, what we will accomplish in this complete tutorial is firstly we will build a simple three-phase RLC branch. Then we'll add a three-phase RLC load. Then we'll add a two-winding transformer, both linear and non-linear, to step-down voltages, and then we'll model a synchronous generator, and we will add this synchronous generator to the grid. Okay, we'll initialize our synchronous generator, and we will add an induction motor to our model. Then we'll convert DC voltage source to AC. Okay, that means DC to AC inverter. Then we'll rectify AC signal to DC signal again, and finally we'll simulate or model a transmission line using bisection. Okay, I'm creating a new model. Okay, let's start with a simple three-phase RLC model. Okay, this is the foundation of our power system, simulating a source connected to a load via transmission line. Okay, here's the plan. We'll add a three-phase source, an RLC branch, a capacitor branch, and measure the device. Okay, and then simulate it. Okay, and now let's add a three-phase source, and you will find under specialized power system and sources. This is our three-phase source. Okay, and we need a series RLC branch. Here is three-phase series RLC branch. Okay, I'm dragging this, and for measurement purpose we need three-phase VI measurement block. This is our VI measurement block, and I'm taking another RLC branch here. Okay, and we will need power GUI block. Okay, and finally we will need a scope. Okay, I'm dragging this into our model. Okay, I'm fitting this, and I'm setting face-to-face voltage like 13.E3 and frequency 60 Hz is okay. I'm clicking this, and I'm setting branch type as RL, and resistance value like 100 ohm, and inductance 1 millihenry is okay. Now I'm connecting this to VI measurement block. Okay, and connecting this branch, and this branch I want SC. Okay, and capacitance like 10E-6, and we will need a ground block, and ground block is present under utilities, and here is ground. Okay, and I am setting as a face-to-face voltage. Okay, now click OK and connect the scope. Basically we are measuring voltage here. Okay, and I'm setting stop time as 1. Now run this model. Our model is run. Now you can see our three-phase output voltage. Okay, that is, and here is another trick. If you don't want to use the VI measurement block, you can use multimeter block. Okay, I'm copying this branch by dragging right click of your mouse. Okay, that's it, and that's it. Okay, and I'm connecting this. Here I will use multimeter block. Okay, now what you have to do is you have to set measurement like I want branch voltages. Okay, now click OK. Similarly our branch 3 measurement branch voltages. Click OK and browse for under sensor and measurement. Here is a multimeter block. Okay, this is our first multimeter block. I will need another. Okay, This is our series RLC branch 2, and double click on this multimeter block, and if you you can see here the voltages of branch 2. Okay, and you have to select this 1 2 3. Okay, this is for branch 2. Click OK. Here you will see 3 is present here. Okay, and if you double click on this multimeter block, and I need for branch 3. Okay, I'm selecting this 1 2 3. Okay, now click OK, and I'm copying this scope and this scope and run this model. Here from this multimeter you will see the voltage of this branch voltages basically. Here this is the branch voltages of our series RLC branch 2, and this is for series RLC branch 3. Okay, so this is the way we can use series RLC branch in our model. Okay, next I will add a series RLC or parallel RLC load. Okay, now I'm taking another model for simulating three-phase load. Okay, I'm browsing library again, and this is our source, three-phase source, and this is our power GUI block, and we will need three-phase BI measurement block here. Okay, and we need three-phase load. Okay, and you will find three-phase load under passive, and this is our three-phase RLC load. Okay, and I'm taking scope here. Okay, I'm fitting. Okay, and double clicking on this three-phase source, and I'm taking phase to phase RMS voltage 13.83 and frequency 60 Hz. Click OK, and I'm connecting to VI measurement block. Here we'll basically measure phase voltages and line voltages. Okay, here voltage measurement under three-phase VI measurement block, if you set phase to phase, it will give us the line voltage. Okay, now click OK, and here in RLC load you have to set the same voltage. Okay, this is 13.883 and frequency 60 Hz. Active power I'm taking as 10 megawatt, and reactive power like 2 megawatt, and this is I'm taking 183. Okay, now click OK. Now connect to the accurate phases, and I'm setting measurement as branch voltages, and these branch voltages will basically measure the phase voltages. Okay, now click OK, connect this, and I'm setting as V LL. Okay, and we will need a multimeter block under sensor and measurement. This is a multimeter block. It will measure the branch voltages of a load. Okay, you have to select these three all, and I'm setting as V phase. Okay, now I'm setting stop time 1 and run this model. Okay, double click on this scope, and I'm setting a view layout as this, and you can see this is the VLL from the VI measurement block, and this is giving us the line voltages, and this is the V phase. Okay, as branch voltage measure the phase voltage. Okay, you can see this is magnitude as like 1, and it is above 1. Okay, it's ensure ours that simulation is okay. Now we will add transformer to step down voltage. Okay, for that I'm taking another new model, and I'm browsing my library, and we will need again a three-phase source and three-phase VI measurement block, and a transformer you will find under power grid element. Okay, this is our three-phase transformer, two winding, and this is our two winding transformer. Then I will need a three-phase series RLC load. Okay, and obviously we will need power GUI block, and I'm feeding this, and three-phase source like face-to-face voltage 13.E3 and frequency 60 Hz. Okay, I'm clicking on this, and okay, and setting voltage like face to face, and I'm not interested in current measurement. I'm clicking OK, and this is a three-phase two winding transformer. Okay, and you have to you can change the winding parameter here. You can choose a yn and so on, or delta 1 or delta d11 and so on. Okay, and I'm going to parameter. You have to select nominal power and frequency here. This is VA, and I'm taking as 100 VA. Okay, and frequency 60 Hz is okay. And winding one parameter, our winding one parameter is I have already set it as 13.E3. Okay, and you have to select the winding 2, and I'm interested in winding 2 voltage like 2400 volts. Okay, so this is our primary voltage, our from left side 13.E3, and this is in right side. Okay, and now click OK and connect the load and see. Okay, and you have to choose the nominal face-to-face voltages as the secondary of the transformer. Okay, I'm setting as 2400, and active power like 10 is 6, and reactive power I'm setting as 2 is 6, and capacity power like 0. Okay, now click OK, and measurement like a branch voltages. Okay, okay, then we will need a multimeter block. Okay, this is a multimeter block, and scope, you will find scope under double clicking and scope. Okay, and I'm selecting multimeter like all these three voltages and click OK. Okay, and this is our VI measurement block output, and I'm setting stop time as 1 second. Now run this model. Okay, this is from VI measurement, and left hand side it is 13.8 E3. Okay, and you can see the voltage wave from here. Okay, and this is our load set, and which is less than 2400 voltage. Okay, as you can see here. So we have successfully stepped down our voltages. Now I want now I want to simulate this transformer into saturation. Okay, I'm copying this and paste it. Okay, okay, for that I'm setting multimeter block here. Okay, and this scope, this is the VABC, and this is load signal. Okay, I'm setting as VL, and to see the saturation behavior of the transformer you have to double click on this, and you have to check this. Okay, simulate saturation and simulate hysteresis, and okay, I'm not setting any initial value of fluxes, and now you have to here all measurement vary fluxes. Okay, now click OK. Now run this model. Okay, sorry, view layout, and this have to fit this. Now you can see from source side its voltage waveform is not so good. Okay, as you can see here, this is because of the transformer saturation. Okay, and now we will add a synchronous generator block in our model and initialize it. Okay, then we will add it to our grid, and for that I am taking a new model again and browsing library, and this is synchronous machine is under electrical machine, and you will find synchronous machine PV fundamental. Okay, and we will need 3-phase VI measurement block here, and under passive we will need a series RLC load. Okay, and this is our power GUI block. And okay, now we have to firstly I am taking a constant block to PM, and we have okay, and I will initialize the synchronous machine after some time. Okay, now I'm connecting this to VI measurement block and our load. Sorry, okay, and now we have to go parameter and nominal power like 100 MVA, and its line to line voltage is 13.83. It's okay, and frequency 60 Hz. It's okay. Now click OK, and I'm setting as face to face voltages. Current measurement no. Click OK, and 3-phase load I'm setting we have to put it 13.883. okay, and frequency 60 Hz is okay. Active power 40 is 6, and reactive power 15 is 6. Okay, and capacitive I'm setting as 0, and measurement like branch voltages. Click OK. Now I'm adding a multimeter block. Okay, and a scope. Okay, this is a VAVC, and from multimeter I'm selecting all of this. Okay, now we have to initialize the synchronous machine. Okay, for that we have to go power GUI block and go apps or tool. Okay, and we have to go machine initialization. Okay, or we can also use it load flow analysis, but as the machine is one, we can go for machine initialization. Okay, and we have to set the problem is we have to add any parallel load. Okay, we cannot connect the series RLC load to the synchronous machine. Okay, for that we have to go for like a parallel RLC load. Okay, and connect this to our respective ABC. Okay, and double clicking this, and like its face to face voltage like 13.8E3, sorry, 3, and frequency 60 Hz. Okay, and active power I'm setting 10E6, and reactive power I'm setting as 0, as well as it's 0. Okay, now click OK. Now go for machine initialization. Okay, we have to select it as swing bus. Okay, and nominal voltage 13.83. It's okay, and we have to set active power. Okay, here we have used 40 megawatt, and this is our 10, so active power is 40 plus 10, 50 megawatt. Okay, so I'm setting at 56. Okay, now update and computer and apply. Now I'm closing this. Now you can see our P and BF has updated. Okay, now we can run our model. So we have to add a bus selector block to see the behavior of the synchronous machine. Okay, I'm deleting this signal and I want under mechanical and rotor speed. Okay, I'm selecting this and click OK, and I'm adding this scope here. Okay, stop time I'm setting as 5. Now run this model. And rotor speed about 1 to 1 point something pu. Okay, so we can say this is okay for our machine. Okay, now we will connect our synchronous machine to our grid. Okay, for that I'm taking a new model again. Okay, and browsing library, and we have to take a 3-phase source here. Okay, and under electrical machine find synchronous machine. Okay, basically the three-phase source uh, we want to consider it as grid. Okay, and we need a VI measurement block here. Okay, and I'm taking another VI measurement block here. Okay, and under sensor measurement I want to measure power 3-phase. Okay, I'm connecting this, and we need parallel RLC load. Okay, parallel RLC load to load. Okay, and this is power GUI block, and okay, I'm taking a constant block. We'll then initialize it. Okay, no problem, and I'm setting parameter like 100 MVA and voltage 13.83. It's okay. Okay, and we have not changed anything here. I'm connecting this to here. Okay, and I add this 3-phase VI measurement block to measure the power. Okay, and I'm checking phase to phase voltage 13.83. Okay, and frequency 60 Hz is okay. Connecting, and okay, this is VABC and this is IABC. Okay, and I will need a scope here. This is serial power and this is reactive power. Okay, and I'm connecting these to as our synchronous machine. Okay, and we need two parallel load this will be same voltage, sorry, frequency 60 Hz is okay, and active power I'm setting as 25 E6. Okay, and reactive power, inductive and capacitive I am setting as 0, and here I am setting 13.83. Okay, and active power I'm setting 40 megawatt, and inductive power like 15 is 6. Okay, and capacitive I'm negating it here at 0. Click OK. Now we have to connect this here. C, and this is A, B and C. Okay, and then we need a bus selector block, and we need scope. Okay, and under bus selector block delete this signal, and under mechanical I'm interested in rotor speed. Okay, and we can also take output active power and output reactive power. Okay, click OK, and under scope set the input port is 3, and layout I am choosing this. Click OK. Okay, this is rotor speed, this is active power, and this is reactive power. Okay, and that's all. Now we have to initialize it. Okay, go for power GUI block, and then under apps or tool it's okay. Now we have one grid and machine, one machine. Okay, now we machine initialization is okay here, no need to load flow here. We will basically continue our load flow in the next. Okay, when we will add an induction motor. Okay, this is basically synchronous generator. This is P and V generator. Okay, nominal voltage is okay, and active power we have to calculate it manually. It's 25 and it's 40, so it's about 65. Okay, so we have to set 65E6. Okay, frequency is okay, and we have to update it and compute and apply. So our initialization is done. I'm closing it. Now you can see the parameter has changed. Okay, now run this model to see the behavior. Okay, this is the rotor speed, and this is output power, and this is reactive power. Okay, so this is how we can add our synchronous machine to a grid. Okay,